Welcome back to 6 Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today for our video on using multiple exponent laws, the extended version. Today's episode will not have a time limit attached to it, so feel free to take your time, sit back, and let's get going. Our key points when we are using multiple exponent laws is to first familiarize yourself with the exponent laws and how they work. We're going to try to isolate which ones we need for that question. And then lastly, we always need to practice when using our exponent laws to become fluent. So let's look at some examples. We're going to simplify using positive exponents. And I have the following. So the first thing I am going to do in this situation is I'm going to use my power of a power law and multiply my outside exponents into the corresponding brackets. M to the power of 3 to the power of negative 4, I would multiply those exponents together for m to the power of 12. And then I would do the same for n. 2 times negative 4 is n to the negative 8. That will be all over 2 times 2 is 4. So that's m to the 4. And negative 3 times 2 is negative 6. I'm now going to use my quotient law for each of my variables. M to the 12 divided by m to the 4. I would subtract those exponents for m to the 8. And I would do the same thing for n. Negative 8 minus negative 6 is negative 2. And then my last step here, I need to get rid of my negative exponent by taking the reciprocal, giving me a final answer of m to the 8 over n squared. Let's check out another example here. Again, I am going to use my power of a power law and multiply this outside exponent to each what I am calling item inside my brackets. I have 3 variables and a coefficient, so that exponent is going to affect 4 different items on top and bottom. 2 to the power of negative 2, I'm actually going to write that as 2 to the negative 2 to start. Negative 1 times negative 2 is going to be a squared. 4 times negative 2 is going to be b to the negative 8. And negative 3 times negative 2 is going to be c to the 6. All of that is going to be over 4 squared. A squared squared, I multiply the 2 and the 2 together to get 4. I just have a b, and then I'm going to square it. And then lastly, negative 4 times 2 is c to the negative 8. So in this next step, I'm going to just draw my division line. I'm going to have positives and negatives, but we're just going to see where things land. I'm going to take the first reciprocal of 2 to the negative 2. I know that that's going to be 1 over 2 squared. I already have a 4 squared in the bottom, so I'm going to write that in. And then I'm going to write my variables by using my quotient law. A squared divided by a to the 4. 2 minus 4 is negative 2. Negative 8 minus 2 is going to be b to the negative 10. And then lastly, 6 minus negative 8 is going to be c to the 14. Now I'm going to simplify everything. So I look at anything that's going to be left on top. I have a negative exponent. That will end up being on the bottom. Another negative exponent. That will end up being on the bottom. And I have a positive c to the 14. And that will be divided by what I have remaining. 2 squared is 4. 4 squared is 16. And 4 times 16 is 64. My a to the negative 2 will be on the bottom as a squared, and b to the negative 10 will also be on the bottom as b to the 10, giving me a final answer of c to the 14 divided by 64 a squared b to the 10. Let's check out another example. For this example, I'm actually going to give you 2 different ways to do this. So our first way we'll do in blue. I'm going to simplify my top, which means I'm going to use power of a power with this cubed. I'm still going to have brackets, and I'm going to have x cubed y to the 6th. All of that is over x to the 5 y. And that's to the negative 4. I'm now going to use my quotient law inside the brackets. 3 minus 5 is going to be x to the negative 2. And 6 minus 1, there is an invisible 1 here, is going to be y to the 5. All of that is to the power of negative 4. And then I use my power of a power law and get x to the 8, y to the negative 20. And then my last step, I take my negative exponent and I put that power on the bottom. X to the 8 over y to the 20. My next example I will do here in green. My first step will remain the same, so I'm still going to multiply that 3 in, and I would get x cubed y to the 6 over x to the 5 y, and that's to the negative 4. Now I'm going to get rid of this negative right away. So how do I do that? Well, to get rid of the negative, I will just swap top and bottom, which is going to give me x to the 5 y over x cubed y to the 6th. By taking that reciprocal of the brackets, that will get rid of my negative. Now I can do everything as normal, but I'm going to be multiplying with positive numbers. I'm actually going to multiply this 4 into all my terms just to show you that no matter how you do your exponent laws, as long as you do them properly, you will get the same answer. 5 times 4 is 20. So I'm going to have x to the 20, y to the power 4. All of that is over 3 times 4 is x to the 12. And 6 times 4 is y to the 24. And then I use my quotient law. 20 minus 12 is going to be x to the 8. And 4 minus 24 is negative 20. And I know that any negative exponent will go on my bottom. And as you can see here, I have the same answer in blue as I do in green. So just to repeat myself, it doesn't matter the order in which you do your exponent laws as long as you do them correctly. Let's check out another example. In this case, I'm going to multiply my 2 in to each item in my brackets. Negative 2 times 2 is going to be p to the negative 4. And negative 1 times 2 is q to the negative 2. P squared. And lastly, q to the 1 over 2 times 2 is just going to be q. I'm going to use my product law now, and I'm going to add my exponents with the powers that have the same base, which I have circled there. Negative 4 plus 2 is going to be p to the negative 2, and negative 2 plus 1 is q to the negative 1. Both of these are negative exponents, so they will go in my denominator as the reciprocal for p squared q, giving me a final simplification of 1 over p squared q. Let's simplify this next example. Here I'm going to use my power of a power and multiply that cube into each specific variable in my brackets. 1/3 times 3 is just a to the 1. Negative 1 times 3 is b to the negative 3. Negative 2/3 times 3 is going to be a to the negative 2. And 1/2 times 3 is going to be b to the 3 over 2. I now use my quotient law to subtract the powers or the exponents of the powers with the same base. 1 minus negative 2 is going to be a cubed. And 3 minus 3 over 2 is going to be b to the negative 9 over 2. I'm going to put that negative exponent on the bottom. So I have a cubed over b to the 9 over 2. And then I can make that a little more simple, depending on your teacher, of taking the root of b to the 9. Let's look at our next example. I'm going to simplify my brackets first. We have to be a little careful as the powers with the same base are not lined up, but it doesn't change our process. So we have a cubed and a to the negative 2. 3 minus negative 2 would be a to the 5. And then negative 1 minus negative 2 would be b to the 1. And all of that would have a power of negative 2/3. Now I'm going to take the reciprocal of what's in my brackets to get rid of that negative. So I'm going to have 1 over a to the 5b. All of that is to the power of 2/3. And then I'm going to distribute that power of 2/3 into each of my items. This is going to give me 1 over a to the 10/3 and b to the 2/3. I'm going to do a final simplification of that one, of saying it's 1 over the cube root of a to the 10b squared. On to our last example here. We are going to simplify using positive exponents. In this example, I'm actually going to get rid of my negative first, by taking the reciprocal of what is in my brackets by just flipping top and bottom. That changes to x cubed y to the 4 over x to the 6 y to the 5. And by doing that, I have gotten rid of my negative exponent. I'm now going to do my quotient law. So I'm going to subtract the powers with the same base. 3 minus 6 is x to the negative 3. And 4 minus 5 is going to be y to the negative 1. And all of that is to the power of 1/3. Both of my exponents in my bracket are negative, so that will take the reciprocal of each of those by putting them in the denominator. And then I'm going to distribute the exponent into each item in my brackets. For 1 over 1/3 times 3 is just going to be x to the 1 and y to the 1/3. And then lastly, depending on your teacher, they might want you to simplify it to x cube root y. Those are all the examples we have today for using multiple exponent laws, the extended version. Please follow us on Instagram and TikTok at 6Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing. And until next time, keep solving and evolving.